Hi, hello everybody. So this is the video dealing with section 2.2, quadratic functions. And in this video, we're going to go over the definition and the graphing techniques. Now, just keep in mind that this is a review for what we have covered or you have covered in Math 119. So a quadratic function is a polynomial of degree 2, which means that the highest exponent is the square. All right, so the traditional format of the function is, as you see here, ax squared plus bx plus c in decreasing order of exponents, where the coefficients a, b, and c are any real numbers, but the coefficient of a cannot be 0, because if it is, then I have just a line, a linear equation. So the graph of a quadratic function is called a parabola, and it's going to be one of the two forms, either facing up if a is positive, or facing down if a is negative. The parabola has, when in a parabola that is opening up, the vertex is the minimum point. On a parabola opening down, the vertex is the maximum point. In the axis of symmetry, this dotted line that you see right here crosses the vertex, crosses the parabola at the vertex. So this is the graph. So either one of the two possibilities, opening up or down, but the standard form of the parabola is different from the traditional form. So the standard form of the parabola looks like this: a parentheses x minus h squared plus k. And this is useful if the function is already in this format, because the vertex will be located at hk. Okay, but we don't have to work with this. So I realize that students probably prefer the traditional form. So we're going to be graphing parabolas using the traditional format of the equation. So for the traditional form of the function, we may have to make sure that the function is in the ax squared plus bx plus c format. If it isn't, we'll put it in that format. Then we'll determine if the parabola opens up or down. We'll find its vertex that has this formula. I'll review the formula. We'll find the x-intercepts if they exist, and we find the x-intercepts by solving the equation f of x equals 0. It may not be possible, right? And then we'll find the y-intercept, and the y-intercept is just f evaluated at 0. And then we'll plot a curve through these points that we find. Okay, so observe the note that I have over here. You can do points, steps 1 through 4 in any order that you want. However, on step 3, you just have to understand that the quadratic function may not have a root. All right, so let me just review with you real quick what a root is. So if you have a parabola, all right, so the parabola either opens up or down, and where they cross the x-axis, those are the roots. Okay, but what happens if you have a parabola that doesn't cross the x-axis, like this one over here? So in this case, there were two roots. For this one, there is no real roots. Okay, and that's possible. That can happen. You can have a parabola that has only one root. So for example, a parabola that just touches the x-axis has just one root. So that's also possible. So when you're plotting, you have to understand that it may not be possible to find the answer to step 3, right? Because there may not be x-intercepts, and that's okay. Okay, we'll just use the vertex and the y-intercept and the axis of symmetry to sketch a graph. Okay, so let's take a look at the examples I have over here, and I'm going to make it smaller because I want you to see the steps. And you will see that I didn't give you a graphing paper. And the reason I didn't give you a graphing paper is because sometimes it's very hard to trace a line, a curved line through these points, um, it's already complicated on real paper. On digital paper, it's even more complicated. So we don't need, I'm going to show you a technique that's easier for you. All right, so let's take a look at example A. So notice that example A, the function is given to you in standard form. So I need to put it in the traditional form. So this is my step 0. Okay, so x minus 4 is square is just x minus 4, and I'm going to FOIL it. So that would be x squared minus 4x plus 16 minus 1. We'll combine like terms. And we do the positive 16 minus 1. So this is the format of the function I want to work with. All right, the traditional form. Now I'm going to identify, just erase this. I'm going to identify A, B, and C. So A is the coefficient of x squared, so there's an invisible one there. B is the coefficient of x, and C is the number. All right, now I am going to do, so I have the parabola or the quadratic function in this format. I'm going to determine if it is opening up or down. So I know that A is positive. So this opens up. Okay. And I am going to, instead of finding the vertex, I always prefer to find the y-intercept first because it's easier. So the y-intercept is the function evaluated at 0, so g of 0. And you can use this format here if you want. So this will be 0 square, right? So just replace x with 0. Minus 8 times 0 plus 15. So obviously these two cancel, and I'm just left with the number 15. So y-intercept is 15. So I got that. Okay. So I got this, and I got this. I want to do the vertex now. So for the vertex, I'm going to write the vertex here. For the vertex, I have to find the x coordinate, which is minus b over 2a, using the values I have over here. So minus b, so it's minus a minus 8 over 2 times a, which is 1. So this is 8 over 2, which is 4. So my x, the x coordinate of the vertex is 4. And for the y, I have to find the function evaluated at that point. So function g evaluated at 4. Okay, so again, I'm going to use this. But you could use this as well if you want. It's the same thing. So I'm going to do 4 square. Keep in mind that sometimes this form is easier. I mean, from this form, you can immediately see that the answer is going to be -1. But that's okay. If you prefer this form, you can use this form. Minus 8 times 4 plus 15. So this is 16 minus 32 plus 15, which is 31 minus 32, right? 16 and 15, 31 minus 32, which is -1, which is exactly what we got from here, because if I replace 4 for x, I have 4 minus 4, 0 squared, 0 minus 1 minus 1. So my vertex has coordinate 4, -1. I'm going to write it over here because I'm going to need that space to solve for the roots. So vertex is 4, -1. All right. Now my last, so I was able to find the root. Sometimes, like I said before, you will not find the root because there are no real roots. They're imaginary. Okay, so for the roots. Now, what I need to do is I need to solve, so this is the roots. I need to solve g of x equals 0. So x squared minus 8x plus 15 equals 0. And now you can solve it any way, either by factoring, if possible, quadratic formula, or completing the square. In this case, we can try factoring because this is going to be factorable. So it's a nice review. The product, find two numbers whose product is a times c, which is 15. 1 times 15 is 15. Now that could be 1 and 15 or 5 and 3. Now the sum has to be b, which is minus 8. Now this is a review. I am not teaching this topic right here. I'm just reviewing it with you real quick. If you need to review more, then just do some research by yourself or take a look at your 119 notes and remind yourself how to factor using the AC method. Then, to find the pair whose sum is -8, I go from the possible pairs of the product, and I can see that I have to use 5 and 3, but the sum is negative. So how do I get a sum of -8 with these two numbers? Well, only if the two numbers are negative. And now, sure enough, when I multiply them, I get the positive 15. Okay, so once I found the pair, which is -5 and -3, I then rewrite the middle term. So instead of writing minus 8x, I'm going to write minus 5x minus 3x plus 15 equals 0. And then from that point on, you may remember that we factor by grouping. So first pair and second pair. First pair, I factor x. Whatever this sign is, bring it here. If it's negative, negative, it's positive, positive. Factor a 3 out of the second pair. Oops, that is negative. And then you can see that x minus 5 is a common factor, so you factor that out. And in the second parentheses, I will get ax minus 3. Now, at this point, I apply the zero product rule, which says that if the product is 0, then each factor is a 0. So I'm going to factor this, solve this, and solve that for x. So add 5, both sides. Add 3 to both sides. And I get my roots. All right, so the roots have obviously y coordinate equals to 0. So this is one root. This is the other root. All right, so now I have everything to sketch the graph of my parabola. So you can begin with the vertex if you want. It's 4. So let's say that 4 is right here, and here's -1. And I know that the parabola opens up, so I'm going to write here 4, -1. I am going to plot now the roots, which is 5, 0, and 3, 0. So let's say that 5, 0 is here. And let's say that 3, 0 is here. All right. And then I'm going to plot the y-intercept, which is the 15. So let's say it's about here. Now and remember that there's a axis of symmetry going through the vertex. So this is the vertex right here. All right, so I'm gonna here's the axis of symmetry. Now I have to trace a line through these points. So you do the best you can. And here is your parabola. Okay. Remember, do not do this. Okay. Don't do, with the point. Don't trace the curve with the point. Don't trace the parabola with the point because it's incorrect. All right. Now, as you can see, it's difficult to draw, if you put the points first and then draw the curve after, the curve becomes a little weird. So normally what we do, we trace the curve first, that is a little bit smoother, and then we position the points after. Okay, so you can do it that way. I'm going to do this. I'm going to show you exactly what I mean with the next function. But this is it. So we have the vertex, we have the two roots, and we have the y-intercept. Okay, so let's do the second function. And sometimes, so I picked this second function on purpose because the second function, we are not going to be able to factor. So in order to find the roots, you're going to have to use the quadratic formula, okay, which is again a nice review. Now, in the second case, the parabola is already in the traditional form. So I'm going to find A, B, and C immediately. So A is the coefficient of x squared, B is the coefficient of x, and C is the number. From this, I can see that the parabola opens down, right, because it's negative. And so this is already done for me. I already found this. I am going to immediately find the y-intercept because it's easy. And remember, you can do steps 1 through 4 in any order. Okay. So this will be f of 0. So -3, 0 squared plus 2 times 0 plus 4. Now, obviously, this is 0 and this is 0, so you get 4. The y-intercept is 4. And now I am going to find the vertex. Okay, so I'm going to do it over here. The vertex. So remember, the vertex has x coordinate minus b over 2a. So -2, so the values of a, b, and c are here. -2 over 2 times a. -2, -6. So this is 1 over 3. Make sure I didn't make any mistakes here. Minus b. All right, minus b over 2 times a minus 6. Okay. Which is, you can do this on the calculator because normally we won't be able to plot 1 over 3. So let's say this is approximately 0.33. And the y coordinate is the function evaluated at 0.33. Now, obviously, it's just is difficult to do, 1/3 square. So you can find the value using the calculator, and this is perfectly okay. Okay, so let's go to the calculator. All right. So -3x squared. So let's see, -3 parentheses 0.33 square plus 2 times 0.33. And what was the part? Plus 4. Plus 4. And that will be 4.27. So we'll write it here, 4.27. So our vertex, and notice it's a weird number, and that's perfectly okay. Okay, this is because we cannot factor this. and you see in a minute. So I was able to find the vertex. And now I have to find, the last thing to find is the roots, or are the roots. I don't know if there's one or two. So to find the roots, I have to solve the equation. Okay, so it's going to be minus 3x squared plus 2x plus 4. Let me just get rid of the calculator from here. Equals 0. Now to solve this, I don't want to start with the minus in front of the 3x squared, so I'm going to multiply everything by -1. And if I do, the negative becomes positive, the 3x squared becomes positive, the 2x becomes negative, the 4 becomes negative. Now you can try to factor this, and I'm going to show you that it's not possible using the AC method again, right? So I have to find two numbers whose product is a times c, which is 3 times -4. All right, so ignoring the sign, it's either 1 and 12, 2 and 6, and 3 and 4. Those are the only possibilities. For the sum has to equal b, which is -2. So out of the possible three pairs, can I get a sum of -2? Oh, I cannot. The 1 and 12 are too far. The 3 and 4 are too close. And even the 2 and 6, right? I can only get, let's say, 6 minus 2, 4, or 2 minus 6 minus 4. So there's no way to get a -2, which means that this is not factorable. So I have to do it another way. Well, what's the other way? Well, you can either do complete the square, which sometimes students don't really like it, or you can use the other method, which is the quadratic formula, which is what we're going to do. Okay, so I showed you that this is not factorable and I have to use a quadratic formula. Now on the exam, you'll have access to the quadratic formula and I don't have to worry about that. Minus b squared minus 4ac, everything over 2a. So notice that the division sign is over everything. Okay, so the values of a, b, and c are here. And for this, you're going to have to use the calculator. So minus b, so it's -2, plus or minus. Okay, and maybe I'm going to do this on the side. So, because I want to put the value in there immediately. So b squared is 2 squared minus 4 times a, -3, times c, which is 4. So this is 4. This is 12 times 4, 48, or 52. So this is square root of 52. Okay. Over 2 times a, which is 2 times a, which is obviously -6. So I'm going to have two values coming from here. I'm going to have the 2 minus 2 plus radical 52 over -6. And I'm going to have the -2 minus radical 52 over -6. I have to find each one, right? And I'm going to do that using the calculator. And you have access to the calculator on the exam. So here we go. Okay, so here is my -2 plus square root of 52. And then divided by, notice, not the operation minus, but the sign, right? The minus from the bottom right here, below the number 3. -6. So this is approximately -0.86. So I'm going to say approximately -0.86. And let's find the other one. So it's -2 minus. Now it's the operation minus. So it's the minus from below the multiplication sign. Square root of 52 divided by, again, -6, 1.53. approximately 1.53. Okay, so now I have the roots, and obviously the two axes, their coordinates are, I'm going to write them down here. So it's negative 0.86 comma 0 and 1.53 comma 0. Okay, whereas the y-intercept, I wrote here 4, but you understand that the coordinate is 0 comma 4, right? The x is 0. So for the y-intercept, the coordinate x is always 0. For the roots, the y coordinates are always 0. So now I have everything to plot the graph. Okay. Now I know this parabola opens down. Okay. And the vertex, where is the vertex? Is at this location. So about 0 and 4 point something. And he opens down. Okay. So I'm gonna say that this is my vertex, and you see what I'm gonna do. I am going to draw the curve already. Okay. This is my parabola. And look what I'm gonna do now. I am going to write the location of the points after I drew the curve. This is my vertex, 0.33, 4.27. This is one of the root. This is the negative one, 0.86 comma 0. And this is the 1.53 comma 0. And this is my y-intercept, which is 0 comma 4. Okay. And this is the way you draw a parabola. Otherwise, it's going to look very, very weird because these values are very close to one another. But if I just draw the parabola and plot the points after, it's perfectly okay because all of the points are clearly identified. All right, so this is how you're going to graph the parabola from the traditional equation or format of the function. If you prefer to use the standard form, you can. So you're going to find, to determine if the parabola opens up or down, you're going to find its vertex. If possible, you find the x-intercepts if they exist, and the y-intercept, and you're going to plot these 4 points. And that's all you need to do for graphing the parabola using the traditional format of the function.